So key concept number 4 is the quotient of powers. When we talk about quotient, it is the answer when we divide. So in our example, we have a to the m power divided by a to the n power equals a to the m minus n power. If you take a look here, what do you notice about the numerator and the denominator if I cover up their exponents? They both have the same base. So the rule here is to divide expressions of the same base. We keep that base and then subtract their exponents. So we have an a in the numerator, an a in the denominator, and that's why we have it equals to the same a. And because we're dividing, instead of adding the exponents, we are subtracting them. So basically, this is the opposite of multiplication. Again, keep the same base and then subtract their exponents. Let's go to our first example. So going back to Jane's problem, 2 to the 4th power divided by 2 to the 3rd power. Do they have the same base? Yes, they do. So because they have the same base, we can go ahead and follow the rule of keeping the same base and then subtracting their exponents, 4 minus 3. Then we can move on to simplify. So what is 4 minus 3? Now we have 2 to the 1st power. Now it's okay to leave your answer like that, or if we simplify it further, we know that 2 to the 1st power is just simply 2. Either way is correct. Let's try our second model problem. Now we have x to the 7th power divided by x to the 4th power. Why don't you pause the video and try to do it on your own? Okay, so what is x to the 7th power divided by x to the 4th power? Do they have the same base? Well, let's take a look. Here we have the x, and I'm going to go ahead and stretch this out, and we have another x. So yes, we have the same base. So we keep the base, subtract the exponents, and 7 minus 4 is x to the 3rd power. Now, if I cover this up, looking back at Jane's problem, was Jane correct? Let's go back to the interactivity. So she claimed that 2 to the 4th divided by 2 to the 3rd is equal to 1. We do not agree with Jane because we found out that it was not equal to 1, but instead it was equal to 2, or 2 to the 1st power. Now you have 3 different tasks that you have to do on your Google document. You can go ahead and do it now, or you can pause the video. You can go ahead and do it now, or you can move on to the next key concept. Key concept number 5 is the power of a quotient. So if you notice, we now have a power of a quotient happening here. What do you notice, though, that is different about this particular quotient? It turns out that they don't have the same base. So we have our A and we have our B. They are not the same. But we do still need to simplify the power or the exponent that is outside of the parentheses to what's inside. So the rule here states to simplify a power of a quotient, You keep the bases and distribute the exponent to each base. So, taking a look here, in the numerator we had a, and we kept it. In the denominator we had our b, and again we kept that base. Now our exponents show that the power on the outside, the exponent on the outside, is distributed to the base in the inside. So remember, to distribute means to multiply. So now we have our m times p. So then we're going to take our p and distribute to the exponents in the denominator. And that's why we have our n times p. Let's go ahead and put this as a dual page as we look at our next problem. So now we have 2 to the 4th power divided by 3 to the 2nd power. Again, do they have the same base? The base in the numerator is a 2. The base in the denominator is a 3. So no, they are not the same. So the first thing we need to do is to make sure that we keep the bases. So we have our 2 over 3. Then we distribute the exponent to each base. So we take our blue 3 and multiply it to the 4. Now we have 2 to the 4 times 3. And then we multiply it to the 2 in the denominator, the exponent of 2. So now we have 2 times 3. And let's move on further to simplify. So that's going to be 2 to the 12th power, because 4 times 3 is 12, over 3 to the 6th power, because 2 times 3 is 6. Then we would go ahead and simplify further. So I'm going to go ahead and erase this because we have it populated in here already. So here's our 2 to the 12th power over our 3 to the 6th power. And if we use our calculators, we figured out that 2 to the 12th power is 4,096, and our 3 to the 6th power is 729. Let's look at our next example. So now here is a little bit different. Now, again, taking a look at our bases, they're not the same. So we need to go ahead and distribute. Take a look here. Well, how did we get that? We know that we need to distribute the exponent on the outside to everyone in the inside. So of course, 3 times 7 gives us our 21. Now the 4 actually has an exponent there as well. The 4 has the invisible 1. Remember that if the exponent is not showing, it's always understood to be just 1. So if it's true for the 4, it's also true for the 3. Now we can continue to distribute further. So in the numerator, now we have 3 times 1. And that's why we got 4 to the 3rd power. Let's do it now to the denominator. So now we're going to do 3 times 5. And that gave us our c to the 15. And then 3 times 1, which is why we got 3 to the 3rd power. Now let's go ahead and simplify the numerical parts further. So if we do 4 to the third power, and then also 3 to the third power, we find that it's 64 b to the 21st power over 27 c to the 15th power. So the zero exponent rule is quite simple. So again, any base raised to 0 is equal to 1. So taking a look here, now we have two rules that we're applying. It's the power of a quotient rule as well as the zero exponent rule. Let's first take care of the power of a quotient. So again, we need to distribute the outside exponent to the inside, both the numerator and the denominator. So now what's 0 times 3? And what's 3 times 2? So you're going to get 2 to the 0 power over 3 to the 6th power. Then simplify further. Applying our zero exponent rule, 2 to the 0 power is equal to 1. And then 3 to the 6th power, if you just put that in your calculator, is 729. So our final answer here is 1 over 729. Let's do the next example. Again, using the power of a quotient rule, distribute this power to each of the exponents in the inside. So let's do the numerator first. So we're going to do 2 times that 0 and 2 times that 7. Then in the denominator, 2 times that 0, but hold on a second, don't forget that 3 has an exponent of 1. So therefore, we also need to distribute that 2 to that 1. Answer, or our work, is 4 to the 0 power, because 2 times 0 is 0, b to the 14th power, because 2 times 7 is 14, over 3 to the 2nd power, because 2 times 1 is 2, then c to the 0 power, because 2 times 0 is 0. So immediately applying the zero exponent rule, which is right here and right here. Remember, anything to the 0 power is equal to 1. So therefore, we have 1 times b to the 14th over 9 times 1. And in the end, we have b to the 14th divided by 9. So now go ahead and practice on your Google document. Remember that you can always look back on this video if you need to remind yourself of anything. Good luck!